Hi again, grade 9s. We're going to take a look at the next lesson in Unit 8, which is 8.3 Properties of Angles in a Circle. The first thing that I want to understand here is a circumference. You know what a circumference is, right? And the circumference, if you remember exactly, is the distance on the outside of the circle. Okay, or in other words, it's like the perimeter of a circle. So that's some basic information you guys should already know. So here we go. Here's our circle, and this distance around the outside, that's our circumference. Now, an arc is just a section of that circumference. Okay, so if I have, let's say, a point on this circle, and I'm going to call this point A, and I'll call this point B. I actually have two arcs here. I've got an arc that goes from here to here, from A to B, and then I have another arc that goes from uh, A to B. Oops, I'm losing my, from here to here. Okay, and we can see that one is longer than the other. So I apologize that my writing is kind of poor here. So this shorter arc is what we call the minor arc. Okay, and that, and also then the longer arc is going to be called the major arc. Okay, and remember again, an arc is just a section of the circumference. So here we go. That this shorter arc from A to B, the shorter arc, that's our minor arc, and the longer arc, that's our major arc. Okay, now let's see how the idea of arcs plays in certain properties that we have to know. So if I used a compass and I drew a circle, and here I drew another circle, I'm going to draw what's called inscribed and central angles. Now, here's the center of the of my circle here. Okay, so my central angle is going to be an angle that's formed by joining endpoints of the arc to the center of the circle. Okay, so if let's say I have, let's say I'm going to put my points out here again. Okay, I'm going to put a point here and call this point A again, and this will be point B. So now I'm going to use this minor arc AB, and I'm going to now connect endpoints or join the endpoints of the arc to the center of the circle. So now if I go from, let's say from the center of the circle here to this point A, and then to this point B, well, now I've created an angle, and this is going to be called my central angle. Why is it central? Because, well, it's in the center here. Okay, so central angle. Okay, I've got my arc AB. Okay, and let's call the center of my circle, let's call it O for the origin, okay, or the center. And now let's put another point. I'm going to put another point on, this time on the uh, on the on the circle itself, and we'll call this point C. And we're going to draw another angle. We're going to connect points A and B. We're going to connect it to C. So if I take this point A connected to this point C and this point B to C here, now what I've done is I've created another angle. Okay, and in this situation, this angle here is called the inscribed angle. Okay, so the inscribed angle is an angle formed by joining the endpoints of the arc to a point on the circle. And this time, this point on the circle is point C here. Okay, so let's review again. So if this is my inscribed angle, and this is my central angle. Now, what's very important here is that both of these angles share the same arc. So they share the same arc, they share AB. And what we say when when two angles share the same arc, we say that they're subtended. And in this case here, they're subtended by the minor arc AB. Now, there is a relationship between the inscribed and central angles, and we're going to take a look at that in those properties. So let's take a look at this angle. Now, um, or this circle and the angles in here as well. First thing I want you guys to understand is I've got two angles here. I've got this angle here. I've got angle POQ, and I've got angle PRQ. And they both share this same arc. They share the arc PQ, and PQ is a minor arc. Okay, so the minor arc PQ, and if we take a look at this angle here, okay, we can tell that this is the central angle, and then this angle is going to be the inscribed angle. Okay, share the same arc. One angle goes to the center, one angle goes to a point on the outside. And so the one that goes to the center is called the central angle. The one that goes to the point on the circle is called the inscribed angle. Now, when they share the same arc, there's a relationship between the two. We would say that the central angle and an inscribed angle are subtended by the same arc. The central angle is double the measure of the inscribed angle. Or we could say the inscribed angle is half of the central angle. So in this situation, if I take a look at angle PRQ, so PRQ, let's say PRQ is 30 degrees. If PRQ is 30 degrees, well, the central angle is double the inscribed. So that means POQ is going to be 60 degrees. Okay, so the angle POQ will be 60 degrees when PRQ is 30 degrees. Okay, so let's take a look at it another way. Okay, if we said the inscribed angle is half of the central angle. Okay, so let me just erase this, okay, so we can understand the relationship here. Okay, so here, once again, here's my central angle. Here's my inscribed angle. If in this situation here, if the central angle is, let's say it's 80 degrees, well, then the inscribed angle is going to be 40 degrees. That's the relationship. The inscribed angle will always be half of the central angle, and the central angle will always be double the inscribed angle. Okay, so that's an important relationship to understand. Now, let's take a look at this one. In this situation, all inscribed angles, if they're subtended by the same arc, all those angles we say are going to be congruent. When something is congruent, that means it is the same as something else. So in this situation, all these angles are going to be equal to each other because they all come from this arc, arc PQ. And from PQ, any angles formed by the arc PQ, all these angles will be the same. So that means if this was 30 degrees, well, this angle is going to be 30 degrees, and this angle will be 30 degrees because they're all subtended by the same arc PQ. Okay, so they all share the same arc. So that means that angle PTQ is equal to angle PSQ, which is equal to angle PRQ. Okay, now the last property we're going to take a look at is this one, angles in a semicircle property. So all inscribed angles subtended by a semicircle are 90 degrees. So what that means is if the arc is a semicircle, okay, if the arc is a semicircle, or if it has a measure of 180 degrees, all the angles inside are going to be 90 degrees. So similar to our last one, where all the inscribed angles from the same arc were the same, well, it's the same thing here, except that if that arc is 180 degrees, or if the arc is a semicircle, all these angles inside will be 90 degrees. So that means then angle BHA is equal to angle BGA, which is equal to angle BFA. And because the arc is 180 degrees, that means all these angles will be 90 degrees. Okay, so that's our lesson for today. Okay, and I hope you guys understand something. If you have any questions, you know how to get a hold of me.